Now what we're going to do is arguably one of the harder parts of this chapter, and that is deciding between the four mechanism types. So we're going to look at how to analyze reactions for competition between the mechanisms to predict what's going to be favored. And this table here summarizes a bit of what we know, as well as some other experimental factors. First, we know that for Sn1 and E1, we need to be able to form a carbocation. We can do that with the tertiary, secondary, allylic, and benzylic substrates. So those will undergo Sn1 or E1 reactions. E2 can take place with pretty much any of the substrates except methyl halides, because here's the alpha carbon. There's no beta carbon with beta hydrogen. And then Sn2, we need the nucleophile to be able to add to the carbon containing the halogen, and that will work for pretty much everything except the tertiary halides, which are too hindered. So that's how we'll use the substrate to figure out, what particular mechanism is best. Second thing is some experimental factors. So in the case of a primary halide, if you have a strong base or nucleophile, and remember, when you have strong, that's going to be leading to E2 or Sn2. And when you have a weak base or nucleophile, that will lead you to the E1, Sn1 mechanisms. So for primary substrates, if it's a strong base or nucleophile, Sn2 favors over E2. Why is that? The nucleophile can come into the primary carbon fairly easily. Also, the double bond you get is not going to be very substituted, so Sn2 tends to be favored. For secondaries, E2 is favored over Sn2 with a strong base or nucleophile. Tertiaries with a strong base or nucleophile, E2 is favored over both E1 and Sn1, because these two mechanisms, you have to wait for the carbocation to form. Versus E2, if you have a strong base or nucleophile around, that's just immediately going to do the elimination without waiting for a carbocation to form. And then finally, if you have secondary benzylic and allylics with weak bases or nucleophiles, you're going to get a mixture of Sn1 and E1. You can't really differentiate those two. The one way to do this is by adding heat. Heat will favor an elimination product over a substitution product. So for example, a primary substrate, strong nucleophile, if there's no heat, you would pick the Sn2 mechanism. But if you add heat, that will favor elimination, and you would get the E2 product instead. So this chart here is kind of a guiding chart for figuring out these mechanisms. This is going to be provided on the exam. So you're going to have to do some predictions to predict the products and the mechanisms, but you will get this particular chart posted with the exam. To figure out which reaction you're dealing with, you're also going to need to be able to know which species act as nucleophiles, which act as bases, and which can act as either. So it's a fairly simple breakdown. Some things are strong bases and strong nucleophiles. Primarily, these are going to be negatively charged oxygen and negatively charged nitrogen. Then we have one species that is a strong base only, and that is the bulky base, the butoxide that we talked about. So because it's so bulky, it's just not a good nucleophile. And then finally, we have things that are strong nucleophiles only. And that's basically anything else, so any other atom with a negative charge. So for example, if you have S minus, that's really only a good nucleophile. It's not a good base. Cn minus. halide ions. These things tend not to be very good bases, but they are really good nucleophiles. So this will help us narrow down our mechanisms in that the strong bases and nucleophiles, these prefer E2 and Sn2. The strong bases only prefer E2. The strong nucleophiles only prefer Sn2 only. The weaks, really just consider one category. These are your atoms with a lone pair. So that's things like water, alcohols, amines, those types of things. These are going to be the Sn1 E1 mechanisms. This is a list that you want to know, but again, don't try to memorize a bunch of things. Just remember, the strong bases and nucleophiles are O and N with a negative charge. Tert butoxide, the strong base only. Pretty much anything else with a negative charge will just be a strong nucleophile. The neutrals are weak.